Welcome. My name is Chastity. I'm here to help you with mathematics. I will not go through all the problems, just a few. It's intended for you to understand the methodology. And so shall we begin with number 1. They want to know, determine whether or not the function is 1-to-1. Now, the thing is, there are two types of tests. You can either have a vertical or a horizontal test. Be cautious. Actually, vertical tests, I kind of got tricky sometimes in the past, but actually the vertical test tells you if the graph is a function. But to know if it's 1-to-1, you use the horizontal test. And when you do the horizontal test is from left to right. So if you draw a line left to right on this graph, is it going through more than one point? So visually, whenever you're given a graph, you can use the horizontal test. Draw a horizontal line, a left to right line through the graph and see if it hits more than one point. What do you think? Well, as you can see, it is hitting more than one point left to right. Therefore, this is not 1-to-1. Or in other terms, is that if you have points, if you choose points on the graph and two different points is hitting two different points on the x coordinate, is hitting one value on the y coordinate, is also not 1-to-1. So let's see if we can find some points. When x is -3, when x is -3, it looks like that point is on 1. Let's look at another point. When x is +3, it's also going to 1. Let's say, -2. At -2, it's going to, at -2, it looks like it's going to 3. And when it's +2, it's also going to 3. So as you can see, if you have different points on the x coordinate, that's going to the same point on the y coordinate is not 1-to-1. 1-to-1 is when you put in one value for x, you should get one value for y. But apparently when you put two types of values, you can get one value for y, which is not 1-to-1. So visually, if we had to do a little diagram, and you put like -3, 3, -2, and +2, and then we do another one with 1 and 3. Visually, you see -3 goes to 1. +3 also goes to 1. -2 goes to 3. +2 also goes to 3. So visually, it's not 1-to-1. When you put in one value, you will get exactly one value out. One value, well, you have two values. Inputting two values with an output of one value, which is not 1-to-1. You should have one input, one output, one input, one output, but we do not. We have two inputs resulting to one output. Therefore, this is not 1-to-1. So if instead of giving a graph, and you're given a set of coordinates, you can visualize, you can have the first oval that's on the left could be for the x coordinates, and the other oval on the right could be for the y coordinates. And visually, well, hypothetically, let's say what a one-to-one would look like. What would a one-to-one diagram would look like? It would have like -3, -2, 2, and 3 in one oval. And let's say you had 1, 2, 3, 4, and visually, let's say one goes there, another goes there, another goes there, another goes here. You can see each line is crossing only one to the left, to the right. There's not a line going towards two numbers to the left. Just one number to one, one number to one, one number to one, and one number to one. One input gives you one output. Therefore, this would be an example of a one-to-one. But based on our question, if we're given the graph, just do the horizontal test, and you can see if it passed more than one point through the x-axis or through the horizontal line that's left to right, then it's not one-to-one. Also, if you plot these points, also if it happens to be one-to-one, it also validates that it is an inverse function. In order to be an inverse function, it needs to first meet the criteria of one-to-one. So if it's not one-to-one, then it's not an inverse, or you cannot create an inverse function. But if it's one-to-one, then you can create an inverse function. And how will you make an inverse function? Well, let's use our hypothetical example. So let's use this example. And if we have the points, so using this as a hypothetical, and how will you find the inverse? First, you check if it's one-to-one. And as you can see, each line going to one number towards each other. So this will be the x, and this will be the y. So let's get our coordinates from this diagram. We can have -3, comma, where's -3 heading? -3, comma 2. Another point we can have is -2, comma 3. We can have 2, comma 1, and 3, comma 4. So each number is going to one number only. No line is hitting more than once. Each line is hitting only one number. Therefore, it's an inverse. So what it means to be the inverse? So instead of having x, comma y, the x becomes the y, and the y becomes the x. So instead of -3, comma 2, the inverse would be 2, comma -3. You have 3, comma -2. You'll have 1, comma 2. and 4, 3. So if it is 1 to 1, to find the inverse, the x becomes y and the y becomes x. So if the function is 1 to 1, find the inverse. So let's look at the function. We have f of x equals 8x plus 1. Now, the thing is, sometimes the visual is better than the equation. So sometimes it's best to graph it and then use a horizontal test to see if you can find the inverse. So to graph this, you start at 1 and then 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8 over 1. Graph looks something like that. Something like that. And if you draw a horizontal line, you can see it hits 1 point. It hits 1 point. Keep drawing as many horizontal lines as you choose to, and you can see it hits only 1 point. Therefore, we can find the inverse. So let's find the inverse. So inverse f of x is the same as y. Y equals 8x plus 1. So I checked it graphically that this is 1 to 1, therefore we can find the inverse. And to find the inverse, switch the letters. Instead of y, y turns to x, and x turns to y, and you solve for y. And to solve for y is get y by itself. So we have x minus 1 equals 8y. Therefore, the inverse, they tend to put either y to the negative 1 or f negative 1. These are notations for the inverse. So we divide both sides by 8, so we have x minus 1 over 8. And this is the inverse. With number 9, we're given an exponential function, and they want to find a given value. So let's look at this exponential function. We're given f of x equals 1/5 raised to the x. The x currently at the moment is unknown. X equals 1/5 raised to the x. And define f of x, f of 3. So x is we're replacing by 3. So wherever there's an x, we're going to replace it with the 3. So we're going to have 1/5 to the third. Now, if you remember your properties of exponent, this 3 belongs for both the top and the bottom. So in other words, we can have 1 to the third over 5 to the third. And 1 to any power is 1. And 5 to the third is the same as 5 times 5 times 5. So 5 times 5 is 25. And then 25 times 5 will be 125. So therefore, 1/5 raised to the third is 1 over 125. That is the value. we can go ahead and check with a calculator. So if you have a TI-84 or some similar to this form of calculator, you have similar buttons, you can perform the operation directly into the calculator using your parentheses wisely. So parentheses 1 divided by 5. And your exponent button may look like an upturned V to the raised to the third. Enter 0.008, which is a decimal. But if you want to convert it to a fraction, your calculator may have a math button. And you see it's FRAC. That's what you'll use. Hit enter and enter again. And it converts to a fraction. Therefore, you'll see that 1/5 raised to the third is 1/125. Number 11, we're asked to graph the exponential function. So let's look at it. We have f of x negative 3 to the x. So f of x is negative 3 to the x. Sometimes you may have a number with the x, which will be a horizontal shift. Transformation may be reviewed from prior videos, but if it's a number with the x, plus or minus with the x, it'll be a transformation of a horizontal left to right. Negative number, they're shifting to the right. Positive number is shifting to the left. If there's a number outside of 3 raised to the x, then there's a vertical shift up and down, positive up, negative down. So currently at the moment, there is no number in this section. Therefore, there is no vertical shift. And also, there's no number with the x, which means there is no horizontal shift. But we have a negative may change the feature of the graph. So with graphing exponential functions, you can simply make a table and graph the points. We could choose numbers like 0, 1, and 2. Any number raised to the 0 power is always 1. So we got a point at 0, 1. And negative 3 raised to the 1, negative 3 will stay the same. So x to the 1, negative 3 to the 1 power is just negative 3. So 1 and 1, 2, 3. And then 2, well, negative 3 to raised to the second power. So 3 to the second is 9, but we have a negative, so it'll be negative 9. 3, 6, 7, 8, 9. So it's going to look something like this. It'll have a downward motion. It'll expect to look a little downward since it is a negative. So when it comes to graphing, the best way to go is make a little table and see where the point is generally heading further on in the graph. Number 13, we'll solve the equation. So how can we solve this equation? What can we do? So we have 36 equals x to 2 over 5. And our goal is to get x by itself. So the property we're going to use, we're going to take the exponent of the reciprocal. So reciprocal means flip of the fraction. So we're going to take the exponent, instead of 2 to the 5th, we'll have 5 over 2. And you do it one side, you do it to the other. So if you remember, when you have a power raised to a power, you multiply the exponent, which you can see 2/5 times 5 over 2. Well, 2 divided by 2, that cancels. 5 divided by 5, that cancels, which we now have x by itself. And we'll have 36 raised to the 5 over 2. So we can rewrite this as, if you remember how to convert a rational exponent into a radical, generally speaking, you'll have x to the m over n equals the nth root of x to the m, or you can also have the nth root, the square root of x, all over that to the m. So let's convert 36 raised to the 5 over 2. So in our case, our m will be the 5 and our n will be the 2. So if we'll have the inside, will be 36. And the bottom number of 5 over 2, which is 2, is considered to be the square root. And with square roots, we don't have to write the 2, it's implied. Parentheses, and the m is a number on top, which is the 5. So the square root of 36 is plus or minus 2. No, the square root of 36 is plus or minus 6. And we're taking it to the 5th power. So we're taking negative 6 to the 5th power and positive 6 to the 5th power. So now, negative 6 to the 5th is the same as negative 6 times negative 6 times negative 6 times negative 6 times negative 6, which could be pretty tedious, and even for the positive one as well. So I think it'd be best to now go to the calculator. So we're going to put parentheses negative 6 raised to the 5th, which is negative 7776. 7776. And then for this one, we'll have positive 7776. Because when you take a root of an even power, it's plus or minus. So you have a positive, and then we take the plus or minus raised to an odd power. Well, a negative raised to an odd power, the number becomes negative, and a positive number raised to an odd power will become positive. Therefore, in conclusion, you see we have 2 results for our x. Now let's go ahead and plug 36 raised to the 5 over 2 and see if we get the same result. 5 raised to the parentheses 5 divided by 2 parentheses, wait, no, sorry, not 5. Ugh. We're doing 6, 36. 36 raised, I'm checking 36 raised to 5 over 2, if it equals the same results, if we can you check with the calculator. If you don't have a calculator, what I did, paper and pencil, that what you have to do instead. So raised to the parentheses 5 divided by 2. And as you can see, we have the same result. But the thing is, the number underneath the fraction, the 2, it's implied that we're taking a square root. The tricky thing with a calculator when it comes to even roots, it doesn't recognize the positive and negative of the number. So you yourself will have to take that into consideration. For number 15, they want to write logarithmic form. So we're pretty much doing a conversion, no evaluation. Let's convert exponential, what's given is the exponential, and I want to convert it into logarithm. So generally speaking, if you have b raised to an x equals y, and you want to convert that into logarithm, you have log, the b is the base, the y goes here, and equals x. Answer to a logarithm is the exponent. So making sure you know what is the exponential form and match it correspondingly to the logarithmic form. So we're given 5 squared equals 25. Well, we know that 5 squared equals 25, but just again the concept that how to convert this into logarithm. So let's identify our numbers with the variables. The 5 will be the b. The 2 would be the x. And the 25 would be the y. So if we convert to log, you have log, the b is the 5, the y is the 25, and the x is the 2. So all we're doing is just converting from exponential and logarithm, and vice versa. If you get a logarithm, let's go in reverse to get the exponential. For number 17, just simply want us to expand the logarithm. And in order to expand, there's some properties you need to know about logarithm. We have the product rule, the product rule is when you have log of b of x plus log of b of y. When they're the same base, you just could put it as one logarithm as x times y. And you could go forward and backwards. Given the plus or given the product, you can go both ways. Then the quotient rule. So for the product rule, if addition relates to the multiplication, what do you think the quotient might be? Well, we're going to have log. Instead of addition, we'll have subtraction. Instead of multiplication, we'll have division. Then the power rule. The power rule says if you have the number in front of the log, it could be rewritten as log base x to the n. So these are some properties you'll need to keep in mind. So let's look at the problem that we currently have, and they want us to expand it. So we have log base 2 parentheses 19 the square root of x over y. So the thing is, we have division. So with division, what kind of rule you have to use? Well, the quotient rule. And a quotient rule, well, to break this apart, you use subtraction of the same base. So you have log 2 19 square root of x. Since it's division, the quotient, we can use subtraction of y. Now, the second part of the subtraction is in the simplest form as possible. You cannot break it down any further. But the first part, well, let's see, what can we do? We have 19 square root of x. Technically, what operation do we have in the middle? It'll be multiplication, so we'll have to use the product rule. So to expand this, we would add. So we have log 2 of 19 plus log 2 square roots of x minus log 2 of y. Now, the thing is, well, we may need to revise how to rewrite radical into fraction exponent. That's implied to be a 2 here, and there's a 1 here. So that could be rewritten as x to the 1/2. So rewriting this as log 2 x to the 1/2, well, based on the power rule, you'll take this exponent and bring it to the front. So altogether, we'll have log 2 of 19 plus 1/2 log 2 of x minus log 2 of y. 21. So we're given a logarithmic function with the unknown x is given. So let's go ahead and work this problem. Whenever the x is known, just simply replace it with the x in the function. So we're given f of x equals log base 9 of x, where we have f of 9 to the 8th power. So x is we're replacing with this. Therefore, we have log base 9 replacing x with 9 to the 8th power. Now, if we recall with the properties of logarithm, we have a power to a power, you could bring it to the front, which will then have 8 log base of 9, 9. Now, there's another property that I have not mentioned, but I'll share it here, is that when we have log of any number is the same as the base, it equals to 1. So therefore, do you notice that the log of the number is the same as the base? Are these two the same? Yes. Therefore, this could replace with the property that log b of b is 1. So we'll have equals 8 times 1, because log of 9 base 9 is 1. Therefore, 8 times 1 is 8. And that is it to find for x, or to evaluate f of x. So number 23, you want us to solve for x. So how can we solve for x? We have 4 raised to the x power equals 13. Unfortunately, the number 13 cannot be rewritten where you have a base of 4 to a power. I mean, there is a property when you have the same base, you can set the exponent equal to each other and solve for x. But unfortunately, 13 cannot be written as 4 to some power. So what we might have to do is convert this into logarithm. So this, the way how you convert the logarithm is that we have log. The base is the base. So this 4 is the base. So we have 4. And then we'll have 13 equals x. This is how we'll convert exponential to logarithm. And then we could go ahead and put this into the calculator. Now, if you do not have a fancy high-tech i84 calculator, and you have a basic calculator that has at least the log button, you can use the change of base rule. Now, a change of base is when you have log base of some number. It'd be log of A divided by log of B. So to rewrite log of 13 with base of 4, it'll be rewritten as log of 13 over log of 4. So let's use the log button itself, and then I'll show you how to use the TI-84 if you have one. So you take log of 13 and use parentheses and hit parentheses, hit enter, divided by the log of 4, which is approximately 1.8502 if they want the 4 decimal places. Now, if you have the high-tech TI-84 calculator, you will go to Math and scroll down until you see something that looks, let's see, where can we find it? Summation. There it is, log base. So if you have this feature, you can use this. So you can have the base of 4 and use the arrow to scroll to the next box, and you have 13. And then you hit enter, and you can see it is the same result. If you choose to use a change of base rule, if you do not have this feature into the calculator, if you have this feature into your calculator, then go ahead and use it as shown. Rounded to the nearest thousandths. So they want to round to the nearest thousandths. So what is the nearest thousandths? So one decimal place is the tenths. This will be the hundredths, and this will be the thousands. So just up to here is all we need. So number 25, they want us to find x in this logarithmic equation. So how can we do this? We might need our properties of logarithm. Do you remember them? How can you apply it here? So we're given log base 4 of x minus 6 plus log base 4 of x minus 6 equals around the room equals 1. So when we have addition, what property can we use when we have logarithms? We can use the product rule. So with addition, when the logarithm of the same base, we can multiply these two, which will have log base 4 x minus 6 times x minus 6 equals 1. Now x minus 6 times x minus 6 could be written how? Well, it's happening twice. So we could rewrite it as x minus 6 raised to the second power equals 1. Now to solve for the unknown variable of x, sometimes it's best to convert this into exponential and then solve for x. So how can we convert this to exponential? The base is a base. The answer to a logarithm is always the exponent. So the answer to this logarithm equals 1. 1 will be the exponent equals everything else. Now, what is 4 raised to the first power? That'll be just be 4. Now, in order to get rid of the square root, what can we do? We would square root both sides. And when we square root a number, it's plus or minus. So it'll be plus or minus 2 equals x minus 6. So we can have 2 equals x minus 6, or negative 2 equals x minus 6. So therefore, we have x equals 8 and x equals 4. Now, the thing is, we have to check if these are the actual solution to the logarithm. Because when we go back to the original function, you need to replace x with the value that we solved for x to see the log of that number is positive. It has to be positive in order for it to be a solution. So if we replace x with 8, 8 minus 6 is what? It's positive 2. Now, if you put in 4 for x, 4 minus 6 is negative 2. Therefore, this will not work. This is only the actual solution. The thing is, when you're given word problems, I will not go through it, but encourage you for you to do them as yourself. It's simply applying everything we have already learned. It's just sometimes the word problem gave us the function, and you just need to put the numbers correspondingly into the function and use everything you learned about exponential and logarithm to solve for the unknown. If the equation is not given to you, generally speaking, it'll be y equals y0 e to the kt, where y0 will be the initial value, y will be the end result, K is sometimes could be the rate or the percentage, and T will be the time. And once you identify these components of the variables, just input it into this formula correspondingly based on the information provided into the word problem, and use the skills of exponential and logarithms to solve for the unknown variable.